Hi, my name is Callie Wilson, and today I will be talking about my Lab 2 for Physics 1, Motion of a Falling Object. This is my table of contents of all the things I will be discussing today. First of all, the introduction. What's the purpose of this lab? This lab will observe the effects of drag and gravity on an object's motion when it's dropped straight down from rest. The fundamental principles used in this experiment is Newton's second law. The acceleration of an object depends upon its mass and any force applied to the object. This law often relates to the velocity update formula and the position update formula. Here are some of the formulas used in this experiment, namely the velocity update formula and position update formula that I mentioned before, and then as well as the drag formula and the gravity formula to calculate those forces. And it is important to note that the net force is equal to the force of gravity if there is no drag. Continuing with the introduction, we can talk about this experiment. A crumpled up piece of paper is our system, while the surroundings is gravity and drag. Both computational models were made with GlowScript, and the observational model was made with the Tracker app. Some assumptions made were that gravity and drag are the only forces working on the system, and that the paper started at exactly 0 on the y-axis with 0 velocity. Some initial conditions is that the initial position is the 0 vector, and that the vector position is only in the y direction, which is negative because the ball is falling downward. The results can be assumed that the computational model with gravity and drag will follow more closely to the observational model in the results than the model with only gravity. Here is the tracker video following the ball downward. Next to the tracker video is the results taken from the tracker app of the position over the time it was falling. Here, on the next slide, is the GlowScript code for the only gravity computational model. As you can see, in the line 65, there is the time it took for the ball to fall. Next, in the line 71, you can see me calculating the force of gravity. After that, in line 74, you see the velocity update formula being used. And then in line 76, you see the position update formula being used. All this was combined together in this code to get the table you see on the other side. Next was the GlowScript computational model for gravity and drag. The time is still the same, but as you can see in lines 70 through 73, you can see the net force being calculated, starting with calculating the force of gravity and the force of drag, and the ball speed. The ball speed can be found in line 70, starting it off. There's still the velocity update formula in line 76 and the position update formula in line 78. This led to getting the table that you can see on the other side as well. Now for a comparison. Over a very short period of time, there isn't much deviation between the models. It starts off very similar, but over a longer period of time, the computational with only gravity clearly deviates from the rest. The observational model and computational model with gravity and drag remain similar the entire time, possibly because they have the similarity of calculating drag into the computations. You can see that the computational model with only gravity is the blue line, while the orange is the other computational model, and the green is the observational model made with the Tracker app. Some errors possibly made in this experiment is tracking the paper ball with markings by hand could lead to less accurate data in the Tracker app. The hand could have not been completely parallel to the ground when dropping the ball. It could have also, the paper ball itself could have also moved somewhat on the x-axis, which we have not considered this entire time as we're only looking at the y-axis. Now, what if? What if the paper ball was thrown instead? That would actually not affect the terminal velocity at all because only drag and weight will affect the paper ball's terminal velocity. So it would remain mostly the same at the end with our results that we already have. Now, what does this experiment mean? This experiment shows that terminal velocity is affected by the drag on an object. This can be seen in the computational model with drag and the observational model because they had similar terminal velocities, while the model that was computational that didn't calculate drag did not have a terminal velocity similar to those that did. That is all for today. Thank you.